Hey folks, welcome to our monitoring protocol for warming temperatures, upstream fire, invasive Phragmites, and other compounding disturbances in coastal wetlands. You'll notice that all of these disturbances are related to climate change or are compounded by climate change. Our monitoring protocol for coastal wetlands has three scales. So that's the landscape scale, where we observe and monitor watershed and regional influences, the ecosystem scale, where we further establish the baseline conditions and assess the integrity, and then even finer, the site-specific scale, where we monitor indicators, the vegetation, soil, macroinvertebrates, and down to the water quality. Hi, I'm Chrissy Ramine, and I'm presenting on the landscape scale aspect of our monitoring protocol, and the landscape scale is really well suited to climate change impacts because really focuses on, as Turner and Gardner would say, the relationships between spatial pattern and ecological processes. So it can catch those sort of regional climatic changes and the way in which they interact with the coastal wetlands. The objective of landscape scale monitoring is to identify the geographic range of stable states or movement of coastal wetland and foundation species. So wetlands, as mentioned before in class, have multiple stable states, meaning they move around and they change quite frequently. And so at this scale, once we understand those stable states, we're able to understand patterns of invasive species incursion. We're able to understand response to upstream disturbances, such as fire. And again, we'll get into some of these other disturbances within the context of site scale and ecosystem scale. But again, we're really able to understand the climate change impacts that compound with these other coastal wetland impacts. An example, for instance, if there are warming temperatures, we can see those warming temperatures and see how those warming temperatures might coincide with land use pressures and how that might coincide with the ability of wetlands to migrate. And again, we mentioned those upstream impacts. If we weren't at a landscape scale, we might miss those upstream impacts. So if, say, there's an invasive species like Phragmites, we might not know where that comes from if we're not looking at a landscape scale. The first step in our monitoring protocol begins before the monitoring, and that's to research baseline conditions. We begin this process by identifying the region in the watershed. This includes upland connections, the entire watershed, potentially social and political boundaries, potentially hydrology studies. The next is to create an inventory of available data. This could include existing maps, satellite and radar imagery, any available data. And the last is to establish a range of historic, current, and predicted future conditions, without forgetting that coastal wetlands are variable with multiple stable states. This first step is really possible because coastal wetland, this kind of data, is increasingly open source and increasingly better in quality. You can think of Google Maps and just think of how amazing those maps can be. Prior to beginning the monitoring protocol, the first thing that we want to do is decide if we have enough information, enough data to decide what our existing baseline conditions are of our coastal wetland. And if we don't have enough, then that's going to kind of affect what the first step of our monitoring protocol is. Step 2 in our monitoring protocol is to identify the best mapping and imaging methods for the variables that we want to look at within our coastal wetlands, the variables that we want to see how they change. There are multiple methods, imaging methods to use, and they're each sort of sensitive to different variables and interactions within the coastal wetland system. A few of these examples include MODIS, which is a remote sensing, usually plus medium and high spectral resolution data and images. And that's really best at sort of imaging the shifts on temporal scales. Then to supplement that, sometimes we use radar or radar plus satellite, and that's very good at understanding the height differentiations within those coastal wetlands. So it can kind of look at what different species you're looking at, whether it's indicator or invasive. And then the last is pulsar, which is a synthetic aperture radar, and that is really good at looking at interactivity within the system because it can even detect water levels and flooding. One other element to think about is to consider whether or not you'd like to use citizen science. There are a number of platforms and a lot of mappers that culturally participate within the context of volunteer mapping with OpenStreetMaps, Missing Maps, And this can be really useful to look at changes over time and for cumbersome data sets. The next step is to actually begin monitoring the system. Could be monitoring for invasive species or species migrations, for example, and the timing and frequency is really contingent upon the monitoring variable. The last step in the monitoring protocol is the statistical analysis, and this is to see if there's a correlation or a relationship between the coastal wetland and any kinds of controls like sea level rise or invasive species. To review the landscape scale, we research the coastal wetland baseline variable conditions, we establish what those are, we monitor for a particular variable, and we assess and analyze the data for a statistical relationship.